Yes. Hyvää iltapäivää. Good afternoon. Hyvä means it's same as good, and ilta is actually evening, and päivä is day. So this is good evening day, if you translate it. But it is the same as afternoon. Good afternoon. Okay, let's continue with this skills test. We have gone through the I guess 12 problems, and now the next will be 17, problem 17. No, sorry, not 17, 15. Tehtävä or problem 15. 15 in Finnish is 15. And this was an equation which contains only letters 15. Solve variable d from the equation, and it is there. The d is in that place there, and it should be solved from that equation. Let's write the equation here. And how would you solve this problem?
You try to leave D on one side and others the other side.
Yeah.
Left side, yes. But A by C is the minus right side. Okay.
Yes. Yes.
Then B into cross bracket E by A plus G minus A by C.
Yes, I guess that was right. Yeah. Yeah.
Right. Okay.
So if we go step by step, so right, it was D we should solve here. So we will move this A divided by C to the right hand side. So that leaves only d per b, or d divided by b, in the left hand side. And when we move this a per c to the
Minus E by C.
it will be change the sign. So yes, it is plus sign here, so it will be minus a per c. And what now? What did you say?
And D equal to D into E by plus G minus A by C.
Yeah. So we will multiply this with b, this equation. So that means that it cancels from this left hand side, and it goes to the right hand side, and it multiplies this expression here. So the final answer could be written like this. Of course, you may also open these brackets here, but it is not necessary. I think this is okay for result.
Can you explain one?
What?
Can you explain one time again?
Yeah, from the beginning. Yeah. Well, first we noticed that D should be solved from this problem, and we found that D in this part of this equation. So we will leave this part only in the left hand side of the equation, and that means that we have to take this away, and it goes to the right hand side by changing the sign. So this a per c, or a divided by c, goes to the right hand side by changing the sign from plus to minus. And after that we see that we have this d here, and we multiply with b. If you are not sure what to do, should you multiply or divide, and if you have to divide, which will be divided by which part of this equation? It is also helpful to compare with easy numbers. For example, in this equation, if we have, I'll take, for example, 20 divided by 4 equals 5. So in this case, we want to
Both sides are same.
Multiplying both sides by d, right?
yeah. We'll write, want to get this d, and it is same as here in this compare equation, this 12. So we have to multiply these, and the same holds here. We multiply b with this expression. And as I said, those brackets, it's okay for me to leave them. I don't think it is more simple if you open these parentheses or brackets by multiplying with b. It only becomes more nasty expression. By the way, this was solved correctly by 54% of students in last week's test. Most common error was that there maybe sign error was quite usual, that you didn't remember to change the sign, and always these kind of equation you have many times come errors with this, that you don't you are not careful enough to see, do you have to multiply or do you have to divide to get the answer. I think that mostly that those were the errors. Yes, and then we have number 9 was the next one. Oh, I hate this problem. This is not a nice problem, because there are so many letters here, and you have to be careful to write those letters correctly. It's not hard one, but there are so many. There are four different letters, and of course you have to be careful with signs. So this is also simplifying problem. You have to open these brackets and simplify the expression. So simplify was in Finnish sievennä. Simplify, sievennä. Yeah.
Okay. First of all,
So
if I see AC
yeah,
minus 2BC.
yeah.
AC
So
minus 2BC.
so we will take these first. A times C
AC minus 2BC.
minus 2BC. So
Plus 2AD.
these one, let's put these some arrows here. Yeah.
Plus 2AD. Minus 2BD.
What did you say?
Minus 2BD. Sorry, 4.
Yeah, yeah.
4
4
BD, yes.
BD. So everyone will be multiplied by everyone. So,
Minus 6BD.
yeah. I would put brackets here in this stage still, but that is okay. 6 BD.
6BD.
Yeah.
Minus 4AD. Minus 3BC. when the context is out.
Yes. Here we have minus sign in front of this bracket, so or everyone changes the signs. Yes. And what will be the final answer?
AC, AC, minus AC.
Yes, minus. Yeah.
Minus plus DC. Plus 6 AD minus 10 BD.
Yes. Did everyone understand what we did here? Is it okay? Yeah. Just ask if there are something not so clear. Yes, this is the final answer. The order of these are not so important. I usually myself use the alphabetical order, so maybe I would write these in the different order, but it is not. It doesn't change the answer. It is only a way to write it differently, but it's okay. This verse. This was actually correct by 57% of students who made this skills test. And then we are going to problem 16, which is almost similar as the 15. It is also 16 is also this kind of letter equation. There are no numbers there, but only letters. This was actually problem which got lowest percentages in the last Friday's test. Only 37% got this correctly.
What's wrong with that number?
Yes, I don't know. Solve variable p should be solved from this equation. And it was b.
B is what? What is B?
So this
Another line, then
what?
multiply PRB and divided PRB. Then PRB BQ minus PRD.
Yes. Maybe we will do.
Possible divided.
There are many ways to solve this.
There is many ways.
Yeah.
PR as the
PRB multiplied. First of all,
Yeah. Maybe we will do the same as we did in the
Yes,
number
yes,
50.
yes.
Yes. So that
Plus-
helps. We don't need two places with where there are these letter B's. So maybe this is a little bit simpler, but as I said, there are so many ways, and the results of this problem it can be written in many ways. So it is many times a point of opinion, which is the simplest form. So this changes again the sign. In this case, you might multiply with b or
R also multiply A into R plus maybe D into R.
Yes. I'm wondering which is the easiest way. If we
I would put brackets and change the place of P with the bracket.
yes, that's what I was thinking. Yeah. For example, if we compare this kind of situation when we have, for example, 8 divided by 2 equals 4. So here it is possible to change these numbers, the places of these numbers. So here it is okay to change these. 8 divided by 4 equals 2. And here it is also possible to do the same. So if we have this kind of sentence or expression here in the right hand side, and we have p in the left hand side downstairs here, it is okay to change the places of these. So actually this and this change places. So that means it will be q divided by, as you said, brackets or parentheses there, a plus d divided by b times r equals b. Well, now b is in the right hand side, but that is not problem. We can read it from right to left, so b equals this, and so this has been solved, this problem. It is not necessary to multiply these. Of course it is possible, and I think most of students who calculated this correctly, they mostly multiplied these brackets away and then made some kind of simplifying in that expression or division expression, but it is not necessary. This is okay for me. Most important thing in this problem was that just in somehow solve the b, and it is not important in which form the expression is there. Usually students hate these letter equations, but actually they are more easy than number equation. Many times you don't have
I think the other method might be longer, but that is easier than this one.
what would you do?
Where you multiply the denominator PR and take it to the other side.
Yes, but you have to divide this or multiply this also with PR. Or do you mean in this?
Yeah, in that step.
Yeah, it is possible. Yeah,
Yes.
yeah. So
So that you can see everything from step by step.
yeah, okay. I will take. So you meant this. I will write this again. So we will multiply by PR. So there will be Q equals P times R times A plus D divided by B. Yes. And then division. Yeah. And we will get the same result. Yeah. Well, not the same in the same order, but it was because I wrote the differently that, but the same result. Yes. There are many ways to solve this problem. Yeah, well, that was 16. The next one is 12. we have.
And I think I made a mistake somewhere. I realized that when you are writing it, you have to write it properly, because if you don't write it properly, the next step is screw you up in the next step.
Yeah, I know. Yeah. This problem 12 is cubic expression, or the expression where there are some binomial expression inside the brackets, and the exponent or power is 3. So we have 2a plus 3 raised to the power 3. This was correct in surprisingly high percentage. I would say 67, because usually this is not so easy. Many make mistakes in this kind of expression. What would you do?
If you remember the formula, do the formula, otherwise do it separate,
Yeah. It is possible to do it like way 1 is this, that we would write this is third degree, or exponent is 3. It means the same, that we have 3 times those binomials there. But it is very long way to go through this, and you have to start, for example, multiplying these first. Then you get some answer of this, and then with this answer you will multiply this third one here. But let's take that another way.
The formula way.
Yeah, in a formula way. By the way, I probably didn't say, I scanned some pages of this formula book to the Moodle. First 3 pages, if I remember correct, 7, 8 and 9. Those are pages in which are told most of the basic rules of algebra. And in this page 9 in this book, which you, as I said, you can find from Moodle, there are this kind of part: polynomien kerto- ja jaollisuussääntöjä. Repeat. How do you say this? Joo. Polynomien kerto ja jaollisuus sääntöjä. Translated, it is written in different order than in English. Multiplication and division rules for the polynomials. It is in Finnish. Kertolasku is multiplication, and well, this means something like division. Actually, I don't know where there are division. There are no. Actually, there are only multiplication rules if I watch this. And here we see the formula here, and it is written like this in this book. Actually, there are 2 formulas in this same row. One is with the upper sign, so if there is plus inside the brackets, a plus b, so we have to use those top signs there. So here take plus, here is only one sign plus, and here is also plus. If there is minus in that sentence, in that inside the brackets, then we have to take these lower signs there. But now we have 2a plus 3, there is plus sign. So we will use the formula. A plus b cubic equals a cubic plus,
3 squared
yeah,
plus 3b squared plus b cubed.
oh sorry, I wrote mistake. 3ab squared,
3b squared
yeah,
plus b cubed.
yeah. Well, now we have so actually in our case this here is in the place of a in that formula, and this is in the place of b. So all we have to do is to change there so that when in the formula we have a, we have to put 2a in that place, and if we have b in the formula we will put 3 in instead. Sorry, now I forget this is 3. Yes, those are so near each other, this formula, and
Plus
like these. Is it correct now? No, there should be 3. Yeah,
3 squared.
now I think it's okay. Sorry about my mistake. So there is multiplication marked there. And what will be final result?
80 cubed
8a cubed
plus 9 18 square 18a square 18a square 18
Is it 80?
3 2 6 3 6
Square
so 4 36
Yeah.
36 square.
Yeah, six times sorry, 3 times 3 equals 9, and here comes 4.
4
2,
36
yeah,
36 a square
yeah.
54 a
Yeah, 54a.
and plus 27.
Yeah. This is easier way to solve this or simplify this kind of format. Well, actually, it is a case of opinion also that is this simplified, more simple form than this. I'm not sure if it is, but this is how it goes. But you have to be very careful, as you saw. I made many mistakes in this my example here. That was number 12, and then 11. Do you remember what is 11 in Finnish? 11. Yeah.
We had numbers today till
Oh,
1000.
today?
Yeah.
Okay.
Yeah.
200.
200.
Yeah. Okay. Yeah.
100.
Yeah. Okay. Do you all know the Finnish numbers now?
Yeah, long one.
Yeah. Okay. Yes, that was this kind of expression. There are
Same.
yeah same almost they are squared now. It is not yeah. So 3 times a plus b squared minus a plus b plus 9 here it is possible to first take away all those brackets, but so using some kind of formula, for example, for this a plus b squared we have this formula here, but I don't think it is quite useful use that formula right now, but first probably is easier to just simplify this in this form as it is written now. So I would take these brackets away first. So that will there is minus sign in front of those brackets, so it will change these numbers here, or the signs of those numbers. So I would do this so that I would leave this first part still in the same format, but now take away these parentheses or brackets there and change the signs there, so it will be minus 2a plus b squared plus 4a plus b minus 1. This is always the most common error place, this when you take brackets away and you forgot to change the sign. And now we have there we have a plus b squared in the 2 place, and then we have a plus b in 2 place, and then we have simple numbers there in 2 place. So let's combine those. So we have what will we get if we combine these two here. Yeah, 3 minus 2 equals 1, so it is only a plus b squared. And then we have this a plus b part
Plus 3a plus b.
plus 3 a plus b
Plus 8.
plus 8. These numbers here, 9 minus 1 equals 8. And then again I would say that this is quite simple a way to write this expression, but how this was phrased here in the problem, there was only said that simplify the expression. There should have been I should have write this simplify and take brackets away. So if it is written like that, so we have to take these brackets away. And what will we get? A squared.
Plus 2ab.
Yeah.
Plus this guy.
Yeah.
Plus 3a. Plus 3b. Plus b.
Yeah. So we use this formula here, a plus b squared equals this kind of sentence, and we had the same letters here also, so it was very easy to do that. And this is the correct answer, but as I said, I'm not sure which one of these are more simple one. Maybe it can be that someone left this in this format and I gave only half points, but it was maybe my mistake. They should have written that take brackets away or take parentheses away. This was correct in 41% of papers. It was 11. And then we have 19. It was again an equation problem. What is the number in Finnish? 19. Actually, in spoken Finnish, this D letter is quite rare. For example, when I say this word in my dialect, I say it 19. I don't use this D letter. And in this place part in Finland, in Seinäjoki area, many use R letter instead of D. They might say 19 or 19.
Which part are you from?
Well, actually, I'm quite near from Seinäjoki. Hey. Yeah. 70 kilometers from this Seinäjoki. I live, and we speak there a little bit different dialect than in this area. My dialect comes more from eastern part of Finland. Yeah, there is some different. For example, here in what?
Eastern side?
Yes, there and also to Kuopio and those places which are nearer the eastern border of Finland. Yeah. It can be seen from my family name. It ends with nen, Paana nen, and many times family names which.
We have a prayer.
Yeah. Okay.
Juma.
Yeah, I understand. When a surname ends with nen, mostly it tells that family comes from the eastern part of Finland. Yhdeksäntoista. This was correct in 61% of papers. What would you do?
I will have to find the x, so I will first get rid of the fraction
Yeah,
dividend, then I'll have all the x and numbers.
yeah. And how would you do it?
So you have to first multiply 3x minus on the other side you have to multiply 2.
Yeah, this multiplied by 3
Yeah.
and this with 2. Yeah,
So that dividends are 6 on both sides.
yeah. And do you do something with this?
then I can just multiply it with 6, you know.
Yeah,
to get
okay.
rid of it. I think you can just write in one fraction, this one.
Yes, yeah, that is possible. What will I write in the top of this line?
3x minus 4x plus 8.
Yeah. So this I wrote that note here. So this place in this problem is the most common error place. You have to remember that if you have this minus here, so it changes both signs here. So this should be also changed to plus. Very common error is that there are minus sign here.
These guys have some other classes.
And so what we do next? Probably you said already. Multiply by 6. Yeah.
12 plus 6.
Yeah. And after that we have a very simple equation already, so we move this. Well, there are you may also move x's to the right hand side, but
Yes.
I'll do this. you would get plus sign there. So yeah. I solve problems with a very mechanical way, so always to the left hand side. But of course it is. In this case, it would be much nicer to move those x's to the right hand side, so you would get plus sign in front of x, but of course we can get rid of that minus sign also. So we will get minus 7x equals 4. And then we divide by minus 7, yeah. X equals, well, actually it's 4 divided by minus 7. Yeah, I would say this is a correct answer, but usually we don't put these minus signs in the bottom part, rather in the top part. So I would like more this version. But both are correct in my opinion. Yes, this also possible. This is somehow dangerous, especially in written calculation. This minus sign may be so near to this division line that you can't see that there are minus. And also, if you use some kind of formula editor, for example in Word, there may be sometimes so near this minus sign of that division mark that it is impossible to see that there, or hard to see that there are minus sign in front of that. But everything I would like all okay. All are okay. Was that. Then we have number 7. simplify the expression again, and it was this kind of expression there. There are powers and there are division marks there, and there are numbers and n letters. Let's write that. Problem 7, tehtävä 7. 40% got this correctly. Most common, I would say that maybe most of students got this correct, but it was not simplified to the last step. So that's why maybe that percentage is such low, I would say. So we have 3m, right, and exponent is minus 8 minus 3n, 5m 11 plus 7n, m minus 2 plus 6n times m 1 minus 8n. What would you do?
Nearly right.
Oh,
Like 5, 3 times 5.
yeah.
And then because it's indices and it's the powers will add them.
Yeah,
It is multiplication.
yeah. We have the same base here, so this m to the power of something everywhere, and we have here exponents in the top part. We may sum them together or add them together, and then we have these exponents in the bottom part, and we have the same base here, m, so we may subtract or minus them from these. So in my opinion, the simplest way to write the next step is just to write these top exponents in a row, plus sign, and then these will be subtracted, so we will change the signs. So this will be plus 2 minus 6n minus 1 plus 8n, yes. And then we just collect the n letters and simple numbers there. I will put some. What will be the fact?
Minus 3n plus 3n, that's 4n. Minus 2n plus is 6n.
Is it plus?
6n plus, yes.
Yeah. Are you the same opinion?
6m.
Yeah. And how about the number after it?
Minus 8 plus 11, that's
4.
plus 3
That's 4.
plus 3 plus 2, 5 minus 1, 4.
4. Is it okay like this? Yeah. So actually quite easy. If you want, just remember the rule that you add those exponents which are in the same row, if you think it like that, and then you subtract these exponents which are in the bottom part of this expression. Yes, and the last one of these calculation rules is the numbers 13.
But for the study purpose also, you can rewrite it like the numerator and denominator. Add them.
Yeah,
And add them at the bottom.
yeah.
And
It
then we go for the next steps.
Yes, it is possible to do so. So you will get. What will you get if you?
We get 15 divide with the indices on top, divide by m to the powers of the m as denominators.
Yeah. What will you get if you calculate this here?
Yeah, yes. 15n into minus 8.
Yeah. And what is? Yeah. Yes, it is this rule here. Here. Yeah. Yeah. Here we have R and S, and we sum those together, and here is the division, so we subtract those from each other. Yeah. So there are many ways to do this, but actually the results will be the same, or hopefully the same. Well, then the last one, or last of these calculation rules, number 13. It was 43% got this right.
Last ones are not very tricky, but they are low.
Yeah, that's right.
Why. But I think it's because of the rules and this one to the minus plus.
Yeah. This is the 13. We have this kind of expression here. It is quite easy when you know the rules. 3a exponent 4b. Do you use the word exponent or power? Both is okay, yeah. Because I'm so used in Finnish, we say it exponentti. Here again, the ending I in Finnish word, exponent in English and exponentti in Finnish. So it is easy to learn to speak Finnish. Then we have this here and this here. I would draw a division line immediately here, same as I did. Well, actually this was in the problem already, but I would do this, that I would write this long division line there, and this I will put in the top part. It is necessarily there. And what will I get when I open these brackets? Or what happens?
Power to the L1.
Yeah, it is the rule. Well, actually, those rules we apply here. If there are multiplications, so we get the same exponent there, and if we have division, again the same exponent. And here we have both. There is multiplication and division, but the same holds. That every letter will get the exponent 4. X4, Y4, A4, B4. And the same here. All will get exponent 2, or all will be raised to the power of 2. A squared, B squared, 4x squared. y squared. And then we will have again expression where we have letters and numbers, and we will probably, it's useful to take these numbers first. There are 3 on the top part and 4 on the bottom part, so it will be 3 divided by 4. And I like to solve this kind of simplifying, so that I will what letters there will be. There are A and B and X and Y and no other letters. So I will first mechanically write A, B, X, Y. I leave the space between those letters, and then I collect these exponents there. So I just watch what exponents A has. So there are 4 and 2 in the top part, so I will plus them together, and then I have only 4 in the bottom part, so I will subtract them, so we put -4 here. How about exponents for B? Yeah, this is always the tricky one, this where you can't see the exponent, but you have to remember that it is 1. 4 minus 2, yeah. Oh, they're the same. 4 minus 2. So actually it will be 3 divided by 4 a squared, yeah. 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 This is okay answer in my opinion, but if you don't like this negative exponent, you may write it in the bottom one. So it is possible to write this. Yeah. I would write here that both are correct. So what do you think if you right now would do the test? Would you get more or less points at time?
If you don't remember the rules, for example,
Yeah.
you can also do elimination by cancel.
Yeah.
If you don't remember the rules.
Yeah, yeah, that's right. Yeah. Okay. Then we have that triangle here, and a rectangular triangle or right-angled triangle. So let's start concerning this.
I couldn't remember the formula.
Yeah, do you remember? Don't remember.
Refers to everything.
Yeah.
So katwa. No, so katwa. So
Yeah, that this is.
katwa.
Yeah, this is memory rule for
Yes,
cine.
memory.
Yeah, yeah.
I was thinking about it, I didn't get it. I went to, I have to go and read my high school notes.
Yeah, yeah, yeah. I
So, if you have so katwa, you get all of them correct.
yeah. If you remember, actually, I found.
You found it.
Yes, I've noticed that, but of course, as a Finn, it doesn't help a lot.
Doesn't what? Help.
It is this SOH
Yes.
and
SOH.
Yeah, and
C-O,
C
yeah,
A
C-A-H.
yeah G-A-H and T-O-A. Yeah. How do you say so?
So-ka-tua.
Shoka tua. Yeah.
So you don't have to read anything.
Yes.
Yeah.
Let's take suorakulmainen kolmio, and this is suorakulmainen kolmio. This is right angled triangle. Suora means the same as straight line. If someone asks where to go, I may say you can go straight forward, so suoraan. Yes, in Finnish. And kulma, it means like angle. And in Finnish, this suora means, in this case, it means the angle which is 90 degrees. And kolmio is triangle. In this paper I used the word rectangular triangle. That is also okay name, but maybe you are more used this on this right angle triangle. And then how about in your earlier school time, when you have discussed or concerned the triangle, have you used these Greek letters in the place of angles, or these, is it capital letters, big large letters?
This Greek one, alpha, beta.
Alpha and beta. And has someone used big A and big B there? Large A and large B. Yes. In some, for example, in this formula you see sin A. There are, so this means the angle, that A letter there after sin. There are two ways to
Yes, instead of using the capital for the angle, they use theta.
theta.
Yes.
Yeah, okay. Then we have A, B, C, alpha. In Finnish, alpha, beta, we say. In Finnish language, these A and B are called kateetti.
Is it the adjacent to
Yeah, these both are called kateetti. These sides of a triangle which are in a right angle.
Like in Russian, yeah?
Probably, yeah. And I think in some kind of similar, maybe in English also, catet, or I don't know if that word is used. Legs or sides of the.
So do you use
Sorry.
it when the two sides are equal, or because sometimes all the sides cannot be equal? Like in some triangle, you have different types of triangles.
When it's equal, you have 45 equal degrees as the alpha and the beta.
Say that again.
When A and B is equal, you have the alpha and the beta as 45 degrees.
Yes,
Yeah.
that's true. But I need in Finnish this catet.
Yeah.
Do you use it for when the sides are equal, or you use it for
These parts in the triangle are called kateetti.
catet?
This is hypotenusa, hypotenuse. Yeah. Yeah. That now I understand what you meant. So this C is in Finnish or this is not actually Finnish, as you know, but it is written like that. Hypotenusa, hypotenuse, or something like that in English. you can understand what this means in English. This is Finnish.
Formula?
Yeah, Pythagorean formula or Pythagorean theorem. Yeah, actually it's theorem. There, this lause. Pythagorean theorem. Lause in Finnish, it may mean you may use lause word for the theorem in mathematics, but for example if you read the text here, is it sentence? I think we had this earlier. In Finnish this is lause. Yeah, the same word, sentence. In this formula book, actually this I have not scanned this page, but I think there are this Pythagorean, yes, here. Suorakulmainen kolmio and Pythagorean lause. There's actually it is written in the different order, but it's the same theorem or same formula. Here here you can see a Finnish text ala. Maybe you can understand what that means. Area. It is the longer word is pinta-ala or simply ala. It means the same. Pinta-ala or ala. This pinta here is actually in Finnish it's like surface. So surface area, if you say. Yeah. Now let's take this. This doesn't. We don't use this in triangle, but let's take this volume. It's tilavuus in Finnish.
So expression is lause.
Lauseke.
Lause.
Yeah.
And this is lause.
Lause. Yes.
What's the
Lause, many times it means some kind of formula you have, but expression or lauseke, it's just some kind of mathematical expression there. Yeah, not any formula, but just anything. Almost anything can be said that it is lauseke. Well, then we have got those first two problems here. We had this. There are some words in Finnish. I would like to give you length. What is the length of A? Length. Pituus.
I see it behind blocks.
Yeah. In Finnish, long is pitkä. So you can understand the similarities of the word. Yes, if there is something is long, then if you have to know how long that is, you call the name pituus. Well, let's take the opposite of that, short, lyhyt. It's easy to just write the words in which you have learned in as you was when you were a baby. So
But you know, what makes it easier is that, you know, when you are doing something and then you are seeing it and you are understanding it, because the basic of that is the basics in language.
yeah.
If a language teacher will explain, you just tell him long and short, long and short. So
Yeah.
you cannot, the brain cannot take it.
Yeah, I understand.
Yeah, you can see
Yeah,
connections.
yeah, I know. The same holds when you try to. I hope you will try to learn me to speak Polish or I forgot what was your language.
No, my language is it's more difficult than Finnish.
Okay, so
That is Wolof.
Wolof. Yes, it was. Yeah, Wolof. Yeah.
Nangadef. Nangadef.
How do you say, for example, triangle in Wolof?
Triangle.
Also, it comes from
Yes.
English or
Yeah,
some.
they
Yeah,
have this
of course.
language.
Yeah.
They don't have this scientific, because it's not a written language.
Yeah,
You
I
try to
understand.
write it, but it's not a scientific language.
Okay. But you have you have written language, so you have books in Wolof. Yeah,
Online, you
yeah.
can go online and
Yeah.
see Wolof.
I guess there are quite many people who speak Wolof.
Yes,
A millions.
Even Finnish. I meet Finnish people who speak Wolof.
Yeah, okay.
In Finland, I was shocked.
Yeah.
And some Americans, they are very good.
Okay.
This is good.
Yeah. 21. There we know B and C, and we are asked to calculate the length of A. Actually, I like more languages than mathematics. I hate mathematics. No. In some formula books, there has been solved this equation already. I don't understand why, because it's so simple to solve. But somehow, or for some reason in this book, they have solved this problem already. A equals square root of this c squared minus b squared. Well, we have this Pythagoras here. I will just write the name of the man or person. C squared equals a squared plus b squared. So there we will solve that by moving the b squared to the other side of the equation, so we will get c squared minus b squared, and after that we get the square root. Actually plus and minus sign there, but if we are having a triangle problem, it will only be positive number. This word here, square root, square and root, it is actually straight translation in Finnish. Square is same as neliö and root is same as juuri. So it is neliöjuuri, but it is one word, neliöjuuri. No, this means this is square and this is root. In Finnish, it also means same as in English. Root. In this case, it means this sign here, root sign. But in Finnish, I try to draw a tree which have his roots here. I'm a bad drawer, but let's let's think this is a tree. So there is a ground here, and this is a juuri, root.
What about wheat? Wheat, land and wheat, or height or wheat?
Leveys, wide. Or
The length of a square and the wheat in Finnish. Or
well, you mean, for example,
the square.
this my phone. It
Yes,
has
exactly.
some kind of height here and width.
Yes.
Yeah. Okay.
In Finnish.
Um, for example, a rectangle, and this is korkeus, height. How do you? Is it all correctly written?
Because when it is in a plane surface, they only have two dimensions. But when it is like
Yes.
dimensional, then it has different like width, length.
Yeah. Yeah. We would say this is korkeus, height, and this is leveys.
Length.
This is width. Please, if I write this incorrectly, correct me. And then if we have this third dimension, for example,
Exactly. Like a box.
this box here. So there is. I will use in a video record, which those who are looking for a video, I will show this box for students. So there are leveys, korkeus, and pituus, length. This word rectangle, it is suora kulmio or suora kaide. Both words are used. I usually in Finnish, for my Finnish students, I use this suora kaide. That's why that this suora kulmio sounds so similar as suorakulmainen kolmio here. And if you don't listen carefully, you might listen that it is the same. So I prefer use this word suorakaide. Okay, let's go back to our example. So we had this A and equals c squared minus b squared and square root of that. So we will write those numbers there. I will put the dimensions, the meter, in the end of that. So now we have to use some kind of calculator. Here's the result of the 41 point. By the way, this as you see in Finnish, we mostly use this comma in the decimal in the place of decimal point. I think internationally usually it's used to have point or dot. Yeah, but actually I think it is because my school history, I was taught to use this comma when I studied mathematics as a young child. I got used to use this comma, but actually I don't like that way. And nowadays I usually, in my own texts, when I write with the help of computer, I use this dot. So I don't like the comma version here, but still when I write those numbers, I many times use this comma, as you saw here again. I'm so used to it. First, I will put some extra decimals there. 41.9326, etc. And now they was asked to give the answer, round it to 3 decimal places. So there was some misunderstanding what did that mean. So 3 decimal places means that after this dot or comma you have to have 3 decimals. So you have to cut it from that point, and then what is the next decimal? It's 6, so it will turn to up. So it will be 933, the decimal part. So the final answer is 41.933 meter. In this problem, many students got half points from all of these problems. So probably that was the reason that it was not rounded correctly as it was asked. But as you understand, it is a very small mistake. Then the 22 is almost exact problem. There you also have to use the Pythagorean theorem. In this case we know A and C, and you have to find out the length of B, so it is actually the same problem. Different letters, but actually the same mathematical problem. Here we got A and C and was asked to find out what is the length of B. So nothing new in this. Pythagoras said that, well, I will put the original formula there, and then we may solve the problem so that B equals C squared minus 8 squared. By the way, do you have what kind of calculators, or do you have any calculators yourself? Yeah. Yeah. In mobile phone you have good calculators nowadays, so it is not so big problem. And how will I round this to 3 decimal places?
230.
Yeah.
even need to write the zero, so it doesn't mean anything.
Yes, it does, because if you don't write that zero, so it is only 2 decimal places there.
Yeah, okay, I get your point, but
Yeah.
technically
No, it doesn't.
it doesn't
Yeah,
mean
no,
anything.
it doesn't mean anything. Yeah,
I think it's just
it may.
to-
Yes.
I think in my opinion is just to apply the concept of decimal places,
Yeah,
accuracy and other standard uses of decimals.
yeah.
Yes.
Mostly this has something meaningful when you are making some measuring, and you want to write exactly what you got, and if your meter, whatever it is, it shows that you have 3 decimals there, and you don't write that, so someone thinks that you only have 2 decimal accuracy in that meter. That is, but actually, if you take a measure and you measure 37.23 meters, you get the same length as you get
Yeah, you
from
can
this.
put as many
Yeah.
zeros as you want.
That is right. Yeah. So then we go to that how did you say so I've seen that many times, but this is the first time I meet a person who actually has used that rule, because in Finnish that doesn't help so much, because it is in different language. So you first have to learn yourself English to understand that rule.
But you can also do things in Finnish if you know how sign is called and how the opposite is called and how the adjacent is called. So you put it together as one.
Yeah,
one
yeah,
word.
yeah,
And
yeah.
then you go to the next one and put it as one word.
Yes, that is. Yes, I know.
In
Yeah,
any language.
yeah. But this is problem in Finnish, because let's write it here. For example, if I have, I write or draw the triangle here, and for example, if I have here angle alpha here, and for angle alpha, this is vastainen.
So that's the opposite.
Yeah, opposite.
Yes.
And the problem is that this
This goes on for last.
is viereinen. So there are the same letter here.
Yes,
V,
but then
yeah,
what
vahvi.
you do is to remember it, you say, what do you call alpha in Finnish?
It is alpha. Yeah,
Yes, so you will say alpha, which is A, and then VA over VI.
yeah,
So
yeah,
you make that one work.
yeah.
A and VA over VI. Or you
I-
just put it one word.
Is it adjacent?
Adjacent, yes.
Is it okay?
Yes, correct.
Yeah. Yeah. So then we have, I will put those letters here, A, B, and beta. And C, okay, of course. By the way, if you have a right angle sign, this box here, do you use dot inside of it? Yeah, I'm not used to it, because, for example, in this book you see there are no dots, only the square. But
We used to put those. So
yeah, that is okay, of course. I don't know if it has changed, because I have some kind of memory that earlier in my childhood, when in school, maybe I think we used dot in those times, but not anymore. So if we have seen alpha or sine alpha. What will that be? How do we calculate sinus alpha or sine alpha?
A over C. That is opposite over adjacent.
Yeah, opposite divided by how do you say it?
That
Ad-
is S-A-C.
yeah, but how do you say this word?
Adjacent.
Adjacent. Yeah.
Adjacent, yeah. English.
Yeah, adjacent. Yeah. How about cosine?
B over C.
B divided by C. In Finnish, this is sini, as I said, the ending with I again, and cosini. Here again you see that we don't have usually use the C letter, so here again it is K. By the way, do you remember this is also color in Finnish language? Have you learned colors? Sininen. This is blue. But you may also use this sini word. For example, if you have blue sky there, and sky is taivas, so you watch blue sky there, it is sini taivas. Yeah, sini taivas. Sini taivas on
Blue sky.
yeah. Yeah, in this word we mostly we may say that it sininen taivas, but shortly it would be said that oh, it's so nice weather, sini taivas. Yeah. Blue sky. And then we have this tangent. Yeah, A divided by B. If we use these letters here, mostly it's helpful to see that in sine or sinus we have alpha and here we have A. So we actually use the same letters, Greek letter and this, what letter this is Latin letters or what is it? Alpha and R. And in tangent also, alpha and R and A. We say in Finnish R, A, B, C, A, B, C, A, B, C. In Finnish we have some kind of memory rule for this cosine. I will write first this is tangent. In Finnish it is easy to understand, it is tangentti. Tangentti. Tangent. You know, there are two T letters there. Tangentti. But the memory rule for cosine is in Finnish memory rule for cosine. Kosiini koskettaa. This means something that cosine touches you, or cosine touches. So what does this help? How does this help to remember? It means that if you use cosine, here we have alpha. So in cosine you use those sides of the triangle which are touching the alpha, this alpha, B and C. So this helps many Finns to understand or remember this rule. or actually it could also for myself I nowadays maybe easier remember it so that in cosine we have these all letters here, A, B, C, or alpha, B, C. So that's how I remember the cosine.
There is cotangent also,
Yeah, cotangent, it is also, it is in the same as tangent, but in different order. And then there are, do you remember these two others? There are totally 6. Cosecant, yeah. And what is the last? Secant.
and cotangent.
Yeah. There are, you have sine and cosine, and then tangent and cotangent, and secant and cosecant. But actually, these two last are so rare. I haven't ever found any useful applications for these secant and cosecant. But for tangent, cotangent, there are some. Yes, for example, well, actually, I teach mostly for civil engineering students, and they, for example, they have some situation when they are concerning beams which are made from concrete steel beams, and when they are calculating how much steel do you need in that beam, they in some cases they need some kind of formula which is helpful to write in cotangent form.
Yes, and then the application also, I saw some of the application in roofing.
Aha.
When you are doing roofing, because some of the places either before.
In the angle or the deflection of this.
Yeah, if you want to know how many sheets of corrugate you will need for the roof, for example.
Aha.
So you know the roof, sometimes there is a triangle there, most of them is like a triangle, something like that.
Yeah.
And then you have to combine all of them and add them together. So you need to find out what is available.
Aha. Yeah. Yeah.
So that when you are ready, then you add all of them, find the areas of different triangle and add them to get the total number of seats that you need to buy.
Yeah.
Yes. So they use a lot of this.
Aha. Yeah.
So it depends on what you have, which area you have from your measurement. Then you start with that one.
Yeah. Okay. And this in Finnish cotangenti. Usually in older days, this is my old calculator, which I got maybe 40 years ago when I was, I think in high school I was, and it has been repaired with the tape, and yeah. But usually in these calculators there are only these 3 sin, cos, tan there, and these inverse functions. There's arcus sine or inverse sin, cos and tangent. But newer calculators, for example, this Inspire calculator, there is one button there, trick button. If you put that, you will get all 6. There is sine, cosine, tangent, cosecant, secant, and cotangent, and then inverse functions also. But this is very rare. Not every calculator, or not so many calculators have this opportunity.
Or we can use cosinus over sinus.
Yeah, yeah, that's right. So of course, during this time, and this is good calculator still. I don't blame this, but of course was possible to calculate also with those more rare trigonometric functions, but you have to remember what to do. So these problems 23 there, let's see that. There was said that, or we knew in that problem that A equals that kind of number and beta equals that kind of number, and we have to calculate what is B, length of B. So we knew A equals this kind of measure and beta is this kind of this accuracy.
Sorry, I have a train to catch. Is it okay if I
Yeah, of course. Yeah. This accuracy of this angle, it comes from my mathematics courses for civil engineers, because when they are measuring so-called surveying measurings using, for example, theodolites, etc., these kind of measurement equipments, and they in those equipments they use 4 decimal accuracy, and that's why and it is important to have that kind of accuracy to get. Kiitos. Hyvää viikonloppua. If you want to, for example, in building site, to get a measure correct in 1 millimeter precision, then you need this kind of accuracy when measuring angles. So it is not theoretical situation. So, and we have to calculate the length of B. So what will we do? Do we use sine, cosine, or tangent?
What is B?
B is,
That is adjacent.
yeah.
Yes.
No. Yes, but it depends on the angle. For angle it is adjacent. But for B,
If you draw the angle, draw the triangle, because that's what you need to do here. In this case, always you have to draw the triangle and
Yeah.
put your fingers there,
Yeah.
and then you know.
Good.
If you don't do that,
yeah.
yes.
Good advice. Yeah,
Yes,
that's correct. A and B beta. Let's write it so it is near in the scale. So it is it didn't go well, but it is about like this.
Yes.
And for example, for this is A. So then this beta will be this angle. It is not this, because this must be alpha. And B is this.
Yes. So now opposite over adjacent.
Yeah. So what function?
Opposite over adjacent. So opposite is O, adjacent is A. So it's tangent.
Tangent. Yeah.
That's why that formula for me is very important. If I don't know it, I can't go in there.
Yeah. Yeah. Correct.
So it's so part one. So when you fix it, then you will know in this case which one you are going to use.
Yeah.
Once you draw it, when you find this
Yeah.
one, you
That's
show
right.
part one.
Yeah. Okay. So we know from this formula or this equation both beta and RA, and we need to solve B. How do we solve B from this formula?
You cross multiply.
That is possible, yeah.
Yes.
Yeah.
Cross makes B as the subject of the formula.
Yeah,
Times B times A equals to B.
yeah. That is correct. You may think that here is 1 below this tangent beta, so we will multiply B with 1, so it will become simple B, and then we will multiply these, so we will get A times tangent B. Or then if you are not sure what to do, you may again compare with simple equation, for example 5 equals 10 divided by 2. So we want to find out what is the B, so this 10 we will get by multiplying these two, so here happens the same. And then we will just write the
Very close to 45.
what?
I say it's almost the same answer. It's going to be the same answer with tangent.
Yes, yes, it is very near. That is always disgusting when you have very near 45. So of course it helps you that the answer is almost the same as A.
Yeah.
But to draw a picture and to, for example, if you want to draw it in scale, so you have to be very careful, and this is so near 45, so it is with those angles. Do I have? I don't need see if I have here with me. It's here. Of course, with the help of this, you would try to be try to draw the figure in scale, but of course it is quite easy. You probably can measure with the accuracy of half degree with this, but not more not so much more accuracy. It is quite hard to do. Well, let's see what the calculator says. Yes, and this is the result. Q for 1.59146, etc. And if I round this to 3 decimal places, so what will be?
591.
Yeah. And then 24, problem 24. Here we know C and C and alpha, and we want to calculate the length of B. C and alpha. By the way, one or In Finnish word, I don't think if we had that earlier. Degree. It is in Finnish aste. Aste. For example, if I have some calculators here. Some calculators tell the unit of angle. For example, in this calculator, in here in top of the screen you see aste. So it is degree, the unit. This old calculator, there you see degree, from the word degree. And I don't remember what kind of. Here also, maybe you can't see it, but there is written deck also here in front, in top part of that screen. But in some calculators you don't see that unit. For example, these are almost the same calculators. This red one is much newer, but they are actually almost the same calculators. But as you see that in this left one, you don't see the unit of degree there. And that is sometimes problem, because if you have wrong unit, you get wrong answers. And I suggest you that if you don't know if you are not sure which unit is used, just simply, you see here, I have done it already. If you calculate what is sine 30, sine of 30 degrees, it should be half, 0.5. And in this calculator, where you actually can't see the unit, you probably have to just check what is sine 30, and now it gives 1/2. So then, after this, I know that this calculator calculates with degrees. The same holds when you are using some application, for example Excel. And if you write to Excel sine 30, you get something minus 0 point something. It is not half. So this Excel uses radian units, radians. And also these mobile phone applications many times use radians. In this my phone, this simple calculator, you don't have any sine, cos or tan there, but if I change it this way, you see it. This is strange. I wonder why this is made so stupidly. I don't know if you have same kind of calculator in your phone, but here you see a rat, and if I see rat text there, I would think that now it is calculating with radians. But if I write here sine 30 degrees, you see it gives you 1/2. So actually it calculates with degrees. This is strange that when I push this button rat there, now it shows rat here. And as you see now, it calculates with radians, and it gives something. This is what you get if you have unit is in radians in your calculator, minus 0.988. But this is strange that now you see the unit, but if you push the deck, so now it is in degrees, but nothing tells you that. I wonder why this has been made. This has been made so stupidly. Yeah. So let's draw the triangle again, so we get
That one is close. Is alpha.
yeah. Now it is easy to see that.
Easy,
Yes, because there are 3 letters here, C, A, B, if you think like that. C, alpha, and B. And as you see, they are touching each other, so cosine koskettaa, cosine touches. So cosine alpha equals B divided by C. And again we get the same result. We multiply with
cosine with C.
yeah.
C go there and then this one will be side.
Yeah. Right now we get the B with the same way. It was in the same format this formula. So B equals C times cosine alpha. And we get the result 189.40442, etc. And the rounded answer will be the 3 decimal places. 404 meters. Some Finnish words again. This rounding, I haven't translated it in Finnish. If you say in English, round the result to 3 decimal places. In Finnish we would say this round, I think in English it also means something like that. Circle is round, and in Finnish the round is pyöreä. So this round in this case it is a pyöristä. Pyöristä. Round and pyöristä means the same. The result is tulos. And then 3 desimaalin tarkkuuteen. So actually in this Finnish sentence is translated that round the result to 3 decimals accuracy. Here again, decimal word in Finnish, it is desimaali, e in the end. Is there any words you, because I think I'm not going to take those two exercises anymore today because it will take some time, but do you have some words that you would like to learn in Finnish?
Pyörä means bicycle in Finnish.
Pyörä, polkupyörä, yes.
So pyöristä maybe comes from.
Yes.
Or pyörä
This is
comes pyörä.
yeah. In bicycle you have two wheels.
Yeah.
Pyörä, yeah. Yeah. Polkupyörä is. Oh, sorry. Polkupyörä. Polku means this is polkia when you used did this so you may ride a bicycle. This polku means that, and pyörä is this wheel, bicycle. But we may also use a short form, simple pyörä. Auto is car, easy to understand probably.
And tin is pure also.
What?
Tin,
How do you write it?
tin in Finnish is pure. Pure.
Pyörä.
Pöytä,
Yes.
table,
Yes.
pöytä,
Yes.
Small lot of
pöytä, table. Yes, now I understand. Pyörä and pöytä. Yes, there's in the different order. For example, mathematical words, laskin. Laskin is calculator. Laskea is same as calculating or counting in Finnish.
Lasku.
Yeah, lasku. Yeah.
Lasku.
Yeah, it is. Lasku. You may also think that when you are, for example, downhill skiing, this is also called lasku.
It's
You are
also
going
called
downstairs. Yeah.
Okay, down ski.
Yeah, laskea, lasku. And again, when you have to, you are buying something and you get, you are not paying it right now. You get lasku. You are going to pay bill, I guess. Or is it English? Bill.
Yeah, bill.
Yeah.
Oh, we have enough words today.
Yes, I think so. It is not used to go, but I sometimes want to try to teach you some Finnish words.
Yes.
If it is helpful for your days here in Finland, so bit by bit you will learn to understand Finnish words and how they are used. But today I'm not going to have anything else. I will try to add some exercises to Moodle page during weekend, and now concerning mostly possibly equation solving, and then these triangle problems. So you may practice. But I'm not sure. Probably on Saturday I will have time to do that.
Yes, math also brilliant.
Yeah. Hyvää viikonloppua. Good weekend for you.
Hyvää viikonloppua.
Yeah. Hyvää viikonloppua. Viikko is week and loppu is end. So this is weekend.
So in Vasa they have this, I don't know whether they have it in Senegal. There is this language school where you can go there and you sign in there, and then you will have somebody where you will be talking with the person, like in that language. Do they have something like that in Senegal?
I think they have, because I have some kind of feeling that I have heard about that.
Yes, if you can find out
Yeah.
that would be very good.
Yes, I will try to find out if
So
yeah,
the person can either you can meet in the school here,
yeah,
where you can speak.
yeah, yeah,
Go to cafe, take party, and then you speak things like
yeah,
continuously.
that is, yeah,
Simple words.
yeah,
Every day we use something like we go to a place, we talk about mass, and then we talk about a lot of things around there, like how we are doing now, but everything will be sent in the language.
yeah.
1 hour plus 2 hours.
Yeah. Let's find out if there is possibilities for that.